So I'm going to start recording. We're going to be working with two for compounded growth, compounding interest continuously or a certain time frame. There's two formulas we're going to use. I'll pull it up here in a second. Yeah, first one is this. Okay, let me get this going here. A stands for amount. That's the amount you're going to have after a certain period of time. P is your principal. That's what you start out with. For this first problem, Claire takes out a loan for school for $9,000 at an annual interest rate of 6.3%. If the interest rate is compounded annually, that means once a year, right there is annually. How much will the loan be worth in 5 years? In other words, how much will she have to pay back? The formula goes like this. A, which is what you end up with, your ending value, okay? This P right here, this principal, that's what you start with. So our starting amount in this case is $9,000. We'll plug that in a minute. Inside the parentheses here, we have 1 plus the rate over K. And K is a new thing. I'm going to explain that in a minute. And this is to the K T power. And K is just, I'm sorry, T is just time again. And time is in years. So your rate, well, that's going to be this 6.3% here. R is just for rate. But you're always going to divide it by 100 or change it to a decimal. So it should be 0.063. That's what we use for our percentage rate. K, right here and right here. It's in there twice. That's the number of times it's compounded. K just number of times it's compounded per year. So I'll put per year. So if it's compounded annually or yearly, it's only going to be compounded once. And once again, T is just your time in years. So you need to know that. So we're going to plug in what we have here and come up with right here our end rate or end amount, how much she's going to owe after so many years. So A, which we're trying to find, is equal to the principal, which is what you start out with, 9,000. 1 plus my rate. Now my rate we said was 6.3%, or you'd put the decimal 0.063 all over 1. K in this case is 1 because it's compounded annually. And then up here it's going to be 1 times 5. So when I plug this into my calculator, I want you guys to do this right now to make sure you're doing it correctly. You can kind of type this whole thing in at once. I usually multiply these two, but if you don't, this is what it's going to look like. Amount equals 9,000, parentheses, 1 plus, and then it's 0.063, the way you'd plug it on your calculator, divided by 1. You don't have to divide by 1, but I want you to practice that so you can get used to it. I would multiply these. 1 times 5 is 5. Just use your little caret key and then 5. And then hit enter. And then I'd love somebody to tell me how much they have after 5 years, kind of make sure we're all on the same page here. I'm going to plug it into my calculator too, so I got a time frame anyway. Yep. Nope. Now, do you see how I have it plugged into the calculator here using parentheses and stuff? Yep, that's exactly right. You guys are using the caret key, I hope. Yeah. So I just plugged it in too, and you round it to the nearest cent. For this first one where it's annually, right here I'm circling that annually, that means we plug in 1 for the K here and here. 12,000, yes, what is it, 215? 43. Okay? So we'll try it on these next three. If the interest is compounded daily. Now, the only thing that's different there, daily, how many days in a year? There's 365. So K in this case is going to be 365. So let me erase this and we'll kind of set this one up. And if you didn't get the last one to work, we'll try this one. Hopefully it works. So anyway, like I was saying, if it's compounded daily, that means K is equal to 365. I wish I could write with this thing. So plugging it into this formula again, I'll use black this time. The amount we're going to have after 5 years if it's compounded daily. Now, the more you compound the interest, the more money you're going to make. So not a ton more, but you will make a little bit more money, or have to pay money in this case. So 9,000 is what we start with. That's my principal. 1 plus 0.063. That's our 6.3% divided by. It's going to be 365. And then it's 365 in parentheses here times the 5 years. Now what I would do with that is take 365 times 5. And this right here is actually 1,825. That's how many times it's going to be compounded in 5 years. So what you should type into your calculator for this one, I want you guys to try this again because that's the biggest part, is plugging it into your calculator and plugging things in correctly. 9,000, it'd be 1 plus 0.063 divided by 365. Okay, use your caret key, 1825. Okay, someone besides Potter now, give me an answer for this. I don't care if you get it wrong or right. Just plug it in just like that and we'll see what we get. 12,331, is that what you got? Oh, okay. Yep. That's right. I think, let me try it real. You're faster than I am, that's for sure. 1825. Yeah. If you round it, and if you didn't round it, if you got close to it, it'd be the same thing. If you round it to the nearest cent, it'd round up to $1. You'd add that dollar to, this is what I actually get, 1,233.998. Well, if I round it up, that makes this $1. So I just add 1 to that. It should be 12,332. But if you had this, I'd take it. You just rounded it incorrectly. Okay? And that's about it for that problem. Hopefully you guys got that. At least I got 2 people that got it right. Let's move on to the next one then. So I'm going to erase all this. Okay, so we got to figure out what K is here. It's compounded hourly. Now, most of the time we don't compound interest hourly, but we're just going to figure this out. How many hours in a year is what we're going to try and figure out. Well, there's 24 hours in a day times 365. 24 times 365 is 8,760. So our K in this case is going to be 8,760. So it's still 5 years. It should be more money. It's not going to be a ton more, but it's going to be a little bit more. Let's go with red this time. This is going to be A equals 9,000, what you start out with. 1 plus 0.063 divided by 8,760. And up here, it's going to be 8,760 times 5. So I would multiply those two first and then plug it into your calculator and see what you get for an answer. Remember, multiply these two right here first and then plug it into your calculator. 8,760 times 5. What is that? So it's going to be caret key to the 43,800 power. So 800. I put one too many zeros in there. There you go. So go ahead and plug that in. And someone besides Pickar and someone besides Potter, give me an answer for this bad boy, and then I'll be happy. Okay, anybody get an answer? It's going to be 12,000 something again. Go ahead. I didn't hear. Somebody said something. I didn't hear it. What was it? Anyone? There it is. $12,332.32. So it's not much more, even though they compounded it hourly. This next one, continuously, right here, that's the key term. It's compounding interest continuously, like every second, whatever it would be. How much will the loan be worth in 5 years? It's really not that much more, but I'm going to show you the formula that's used for continuously. So hold on a second. Let's move this up a little bit. The formula we use for continuously is called the APERT formula. Here's why. The amount you're going to have after so many years is your principal P, e to the RT power. E is that natural occurring element. We've talked about it before, 2.7, something like that. That's how you compound interest continuously. Now, it looks complicated, but it really isn't. You just got to find the E button on your calculator. And if you see the LN button, it's below the log key. If you hit second and then LN, that'll give you E to whatever power. Well, if we plug everything in we know here, it's going to be this, 9,000 E R times T. Well, it's 5 years and our rate is 0.063 times 5. Whenever I do these problems, I always multiply this and get one number. So 0.063 times 5, I get 0.315. Okay, so plug that into your calculator. You should be able to use the e to the x button, so it's going to be 9,000 e. It'll do the little caret key. You don't have to do the caret key on this one. It should be just using your calculator, and that'll put that 0.315 in the box for you, and just hit enter. So try that one. I'll take an answer from anybody. Yes, that is absolutely correct. If you plug this into your calculator correctly, using that e to the x button, it is 12,332.33 in this case. So it only goes up a penny when you go from hourly to continuously. So compounded continuously isn't that much of a big deal, but it is part of the problem. So if it says continuously, use this, where is it? APERT formula. Okay, if it's hourly, daily, monthly, whatever it is, then you're going to use the formula that we've used earlier in the other three problems. So let's continue on here. Let's do another one. Oops, I don't want that. Okay. Okay, so let's finish this up. If you deposit 100 in an account paying 3.5% interest compounded continuously, how long will it take your account to reach $1,000? Okay, if you deposit 100 in an account paying 3.5% interest. So it says continuously. So we're going to use this APERT formula. Principal e to the RT power. It's probably a little bit easier to use than the other one. How long it take your account to reach $1,000? Okay, so this is a little bit different. This is your end amount, or your A. You start off with $100. That goes in for P, and you want to end with $1,000. So it's going to be 1,000 equals 100 E. 3.5% interest, I'm going to divide that by 100, and that is 0.035. And we want to find T. Now, T is an exponent. So in order to find this, we're going to have to use logs to each side. So we got to get this right here, e to the 0.035 t power by itself first. So we're going to divide both sides by 100. Yeah. Okay. I'll. Okay. Hold on a second here. Okay. I'll come back to it then. You guys can hear me though?